Okay, these are questions that were asked in class to cover from section 2.1. All right, question number 20 on page 75. Okay, on page 75, question number 20. What is this question asking? Well, determine the equations of both lines that are tangent to the graph of f at x equals x squared and passes through the point 1, negative 3. What we're trying to do is find a tangent line that touches this x squared, and it also passes through the point 1, negative 3. So let's get a visualization of this question. Well, we're going to draw the parabola y equals x squared. So this is just a sketch of it. We don't need coordinates or values on there, just an idea of what we're looking at. Here's our parabola. We plot our point somewhere where you would think that point is, which would be down to the right and below the x-axis. And what we will have is two tangent lines. Okay, so this point 1, negative 3, we'll have two tangent lines. One will cross one way and the other will cross the other way. So we have two lines, one green and one purple. The goal is that they touch one point on the parabola. What are the coordinates of that point? We don't know. If we knew the coordinates, we'd be able to find the equations, no problem. So let's go back a second, go through all this, and let's call that tangent point A for the x and a squared for the y. Why is it a squared? Well, that will be because we use f at a, and then find f at a for our second value. So a is our x, and our y is equal to x squared. So in our case, it will be a squared. All right, knowing that, we will then go and find the derivative of our function. Now in 2.1, we had to use first principles to find the derivative. Now we can find the derivative faster. So let's go back and try and do this faster. We get f prime of x is equal to 2x. Well, we don't want f prime at x. We need the slope at a. So f prime at a is going to equal 2a for whatever value that a is. We don't know which point it is, but we know that there are two possible tangent points. So I know this f prime at a is equal to 2a, and I know this information about the graph. What do we do next? Well, folks, f prime at a is equal to delta y over delta x. Because remember, f prime is the slope of the tangent. So the slope of the tangent, we have our 2 points. So we could find the slope using these 2 points here. Delta y means a squared minus negative 3, which turns into plus 3, and a minus 1 for delta x. That is equal to f prime at a. So we took delta y over delta x with the points in black and made it equal to f prime at a because that is also equal to the slope. So we make one side equal the other side. You now cross multiply, expand, collect like terms, and lo and behold, when you collected the like terms, you should see that this is factorable. It's factorable so that we get a minus 3 and a plus 1 is equal to 0. Well, that gives us the value of a equals 3 and a equals negative 1. Now, are these both valid answers? Well, let's look back at the graph. Could one of these have an x value, which is our a, of 3? Well, yes, this one probably has a value of 3. Could our a value be negative 1? Now normally when we're talking about a height or distance or time question, we usually ignore the negatives. In this case, these are coordinates. Coordinates can be negative. So this point could potentially be our -1. So we need both points. We're using f prime at -1, which is -2. So the slope is equal to -2. And the slope at 3 is 6. So we're going to sub the slope for -2 and the coordinates -1, comma 1 squared, which is 1. And once we do that, we sub it into our y minus y1 formula. So that's our equation of a line formula, folks. We plug it in, just like we did in Unit 1. And we expand, collect like terms, and lo and behold, there's our first equation. Y equals -2x minus 1. Now, we sub in the slope for the second one, and the coordinates, which are 3, 9, and we get the value y minus y1 equals m times x minus x1, and we get this equation y equals 6x minus 9. Now, state the conclusion statement, and here it is, folks. So, there's our conclusion statement, there's our questions, and that is it for question number 20. So our two equations of the two equations of a line. Notice their slopes are different, but if you look at our purple and green line, that also would make sense. All right. Okay, now on page 75, there was question number 17 that was asked to show on video. So let's look at this question. In this question, it says, if f at a equals 0 and f prime at a equals 6, find the limit as h approaches 0 of f at a plus h over 2h. All right, we don't know what to do with this right now, so let's ignore this for a moment. Let's look at what f prime at a really is. If you find f prime at a, that f prime at x is equal to limit as h approaches 0 of f at x plus h minus f at x over h. So let's convert that f prime at x, since we know that this is the definition of a derivative. This is our limit, our derivative of first principles. So definition of a limit is of the derivative is this. Now we use that definition and plug in a. So f prime at a is equal to limit as h approaches 0 of f at a plus h minus f at a all over h. Well, we have some of that information already. We have, for example, f prime at a, we know the answer is 6. So we could replace this f prime at a with 6. Now, we also have f at a. We know that f at a is equal to 0. So replace that. So we have 6 equals the limit as h approaches 0 of f at a plus h minus 0 over h. What does that give you when you simplify it? Well, it gives you the limit as h approaches 0 of f at a plus h all over h. So, where do we go from here? Well, let's look back at the question. The question says this. So the limit as h approaches 0 of f at a plus h over 2h is equivalent to the limit as h approaches 0 of 1/2 times f at a plus h over h. So we do know that we separate the 1/2. From the limit rules that we learned in the limit laws that we learned in the last one, we found out that the limits of a product, we can take that coefficient of that product and pull it out. So it equals this. Well, we also know what the answer to this is. We have it in blue over here. the limit as h approaches 0 of f at a plus h over h is actually equal to 6, folks. So we have 1/2 of 6, which we found already. Well, what's 1/2 of 6? The answer here is 3. So again, what we used was the definition of a limit and plugged in what we knew values for. Once we did that, we were able to use limit laws to be able to answer this question. So the answer to 17 is 3. Okay, folks, that's all for tonight. Happy homework. Take care.